Good afternoon, everybody, and welcome to the iCar Tech Center. I am Bud Center, our Director of Technical Products and Curriculum.
I'm TJ O'Rourke. I'm one of the subject matter experts here at the iCar Tech Center.
And I'm Jeff Poole. I'm the leader of the subject matter expert team at the Tech Center. And on the line with us, we have guests.
We do.
John?
I'm John Wilburn with Polyvance. I am the head training instructor.
All right, well, welcome, John, and thanks for joining us. So this is the second in a series of broadcasts that we'll do with Polyvance around plastic repair. And last time, maybe just give us a quick review of what we did in the last video.
Last episode, we looked over one of Polyvance's new plastic welders that John was able to bring with him. We looked at tips on identifying plastic, both in codes stamped into the bumper, or alternatives if you couldn't do that, like a welding test, or possibly looking at service information to see what plastic part might be made of. And then we also went over a little damage analysis considerations when looking at a damaged bumper cover.
Okay, perfect. And I think this time, John, we're actually getting into the actual repair now. We're going to see some stapling and some welding and the actual repair to this bumper cover. Is that right?
That's right. Yeah, we'll be fixturing a crack together and nitrogen welding it and getting it ready for filler and primer.
All right, perfect. Well, at this point then, guys, let's go ahead and roll the video, and then we'll come back and have some conversation after.
Okay, TJ, now that we have the dent removed, we have the crack lined up. We have the crack lined up how we want it. Everything's lined up perfectly. So I'm just going to trim back a little bit of the paint, grind off a little bit of the paint where I'm going to melt in the staples.
Okay.
All right. Let's pull everything together, make sure that it's lined up properly and it looks good. So I'm going to go ahead and insert the first staple. And we have these little V-shaped staples that we're going to use in this little curvature right here. So what I've done here is melted staples about halfway deep into the bumper. Of course, you don't want to go all the way through, but you want to go about halfway deep. allow the plastic to cool just enough so that you can remove the stapler. You don't want to press them in and then immediately try to remove your stapler because you're going to pull the staple right back out. So once you melt about halfway deep into the plastic, let off the button on the stapler, allow it to cool for 5 or 10 seconds, and then remove the stapler itself.
Okay.
So we've got 3 staples melted into the part, and now we can apply the aluminum tape. Push the staples right through. And we are going to use a Bondo spreader here to squeegee that tape down. Push that and get it nice and tight in that curve there. So the reason that we're using staples and aluminum tape is the staples are helping hold the crack together, and the tape is also helping hold the crack together, but it's also serving as a backing so that when we weld the back side, if we get the plastic too hot and we melt all the way through, the welding rod will hit the tape and allow us to continue our weld. Versus if we didn't have tape on it, if we just relied on the staples, if we pushed all the way through, we'd have to stop, let the plastic cool, and then start welding again. So using staples and tape allows us to continue our welding no matter what happens.
Okay, I could see that.
And now we're ready to flip the bumper over and start prepping the backside for welding. Now that we've got the crack fixtured, the bumper flipped over so that we can get to the backside, we're going to begin V-grooving.
How wide and how deep would you want to do that on the backside of a repair?
Very good question. So most repairs that you do, most cracks that you weld, it's only necessary to make a shallow V-groove on the back side of the part because the more you take out of the part, the more you have to add back to it. So if you V-groove deep into the part, then you have to add multiple layers of welding rod, multiple passes of rod to fill in what you've taken out. So it's only necessary on the back side to V-groove shallow and apply 1 bead of welding rod. As far as the width goes, if you're working in a high stressed area, you may want to make a wider V-groove in it, but if there's not a lot of stress in that area, a narrow V-groove will suffice.
Okay.
And so I'm going to go ahead and begin the V-grooving here. So we've V-grooved the tear itself. Now what we want to do is V-groove across this top edge here and put a cross stitch weld or a T-weld, if you will, for extra reinforcement. What that's for is this part can be passed around the shop and handled like a brand new part with putting this cross stitch T on here. It just gives it that extra reinforcement so that you can handle this part like it's a new part, like it was never broken. So, so this is very important to put this cross stitch here. If you were welding a crack in the middle, in the face of the part, cross stitch isn't necessary because it's not in a high stressed area. But here, as we've talked about, this is a very high stressed area, so we definitely want to put that cross stitch.
Yes.
All right, so I would like to mention, TJ, that however wide you make your V-groove, you want to use a welding rod that lays inside of that V-groove. You do not want it overlapping over onto overspray or anything like that. So however wide that V-groove is, choose a welding rod that's going to lay inside that V-groove.
Okay.
And we'll begin welding. Again, preheat, pre-melt the tip of your welding rod. Let's preheat the bumper. And then we can make contact and begin the weld. Now that we have reached the end of the crack on this side, break the rod off. And if if the bumper is thin up here toward the edge, you might want to allow the part to cool some before you do your cross stitch weld. What can happen is it can cause, if you over melt or overheat the edge, it can cause it to warp a little bit. So again, if it's very thin, I would do that. I would let it cool a little bit before I put my cross stitch, my T-weld. But if it's fairly, thick plastic, you can just continue on. There's no need to allow it to cool or anything.
Okay.
All right, so now we can do our cross stitch. And we want to lay this cross stitch weld just right over our existing weld down the crack. And the cross stitch needs to be, an inch to 2 inches on either side of the crack. All right. Let's break that off. Now we're going to use the airless welder, come through and just taper these edges down, especially along our T here. Again, we talked about not building this up thick across here, which we haven't, but I want to taper the edges so that the fitment is spot on when the bumper's reinstalled. Okay. So I'm just going to come across with the airless welder and just lay some of these edges down nice and even. And I'll go ahead while I'm here, catch these edges as well. Now the profile of this edge right here is very close to what it was pre-damaged.
And now we could flip it over and start on the front side right away?
Actually, we want to let this, this damage cool, this weld cool to room temperature before we move it. The reason for that is while the weld is hot, it's weak. It can flex really easy, so if we start moving it right now, trying to reposition it, it could damage our weld, it could cause it to break loose. Once it's cool, it's very strong, but when it's hot, it's very weak. Okay. So we do want to let it cool to room temperature.
Sounds good.
All right, now that the part has cooled to room temperature, we've got it flipped around, right side up. We can remove the tape and the staples.
Why would you remove the staples?
That's a very good question. So the staples aren't necessary anymore. They're not serving really any purpose. The weld is where the strength is here. There are certain repairs where I might leave the staples in, but it is not necessary here. The weld is strong enough to hold this damage together. The staples would not be helping at all at this point.
Do we have to make any changes to the welding machine settings now that we're working on the front side?
It's not necessary to make any changes at this point because the thickness of the plastic is not changing. So there'd be no reason to change the settings. And with that being said, even if the thickness of the plastic isn't changing, let's say that we were moving to an area, let's say the front side that we're repairing is in a tight area, maybe in a fog light hole or something, then we would need to turn the flow down or the heat down so that we didn't melt anything around that the crack. But we're wide open here. The plastic's still the same thickness, so there's no reason to make any adjustments.
Okay.
Take a look at our repair. Okay, and the staples and tape did their job. Everything is still lined up, looks good, so we can go ahead and remove those staples. All right, now that we have the staples removed, we can go ahead and V-groove the front side. So to V-groove the front side, I'm going to swap over to a pointed bit. I used a ball bit on the back side because I was making a wider V-groove on the back side. I'm going to keep it narrow on the front. It's only necessary to make a narrow V-groove on the front, especially on a tear like this. So I'm going to grind a narrow V-groove into the crack, but I'm going deep this time. On the back side, we made a shallow V-groove, so we're going deep on the front. The reason that we grind deep into the front side is because this is where we're gonna grind it, sand it, wipe our filler, cosmetic side of it. So if we were to grind it shallow and put one bead of welding rod into this tear, by the time we grind it down and sand it, and get it all level and smooth, there's not going to be much welding rod left there holding the front side together. So that's why on the front, we grind deep and apply plenty of new material, plenty of welding rod into the front side of it so we can grind it, sand it, and there's still plenty there holding the tear together.
Okay.
So we'll go ahead and V-groove this with the pointed bit. And even though it's not absolutely necessary, I'm going to apply a piece of tape to the back side so that just in case I melt all the way through, the tape will prevent the rod from pushing all the way through and I can continue on with the weld. Okay, we can go ahead and begin the weld. So we're going to preheat the welding rod. Preheat the bumper, and TJ, notice that I am using the narrow round rod because we V-grooved narrow using the pointed bit. A wider ribbon is not necessary here. We want to keep our repair nice and tight, smaller profile. All right. We've got the V-groove completely filled. This weld is complete. Now what we'll need to do is use the airless welder along with the nitrogen welder and shape this weld up and get rid of any imperfections.
Okay.
And that is done. We'll allow that to cool to room temperature and continue on with sanding, grinding, and prepping it for filler. All right, TJ, now that we've got the weld all smoothed down, all the imperfections smoothed out of it, we'll use 36 grit or 50, a roll lock on an angled die grinder, and knock the weld down. Now that we've got the weld grinded down, we're going to use 80 grit on a DA sander and just sand all around the weld and do some shaping on it, do some more shaping on it.
Okay.
All right. Okay, TJ, now that we've got the weld sanded with 80, I'm going to come over and sand the crease that we worked out with 80 as well.
Okay.
Now that we've got it sanded with 80 grit, we're going to switch to 180 grit and feather the paint back wherever we know we're going to wipe filler at.
Okay.
John, looks good. I'll give this over to the technician. He'll follow the product maker's recommendation and then get it ready to go over to the paint department.
Yep, and TJ, this is a good, strong, quality repair, and this will hold up just like a brand new part will. You can bend it, because of course, you know, installing the part, sometimes you have to bend on them to, you know, stretch it to snap it on, and this will hold up as if a brand new part. Good quality, solid repair.
Excellent, thanks, John.
You're welcome.
All right, so now we're back from the second video. That was really, it's impressive to see what we can do with plastic repairs and welding of those repairs.
It was great watching John work as well. He's really a true master when it comes to nitrogen welding.
Yeah. So before we get into any more of the discussion, if anyone has any questions watching live, you can enter those into the chat box and we'll get those questions answered for you. If you're watching on demand, you can send your questions to repairsrealm@i-car.com and we'll get those questions answered for you after watching on demand as well. So if we take a look at some of the questions that we've got at this point, I guess we'll just start with the first question on the list. And we'll ask these questions of you, John. Is adhesion promoter needed before welding on plastic?
Adhesion promoter is not needed. It will actually contaminate the plastic. You want raw plastic when welding. Adhesion promoter will actually create a barrier from your filler rods sticking to your base material. So adhesion promoter is detrimental. It's bad for a nitrogen plastic weld or any plastic weld for that matter. I know with most adhesive repairs, you would use an adhesion promoter, but you do not want to use adhesion promoter on a plastic weld. It will definitely cause the repair to fail.
Okay, makes sense. Our next question is it necessary to apply plastic repair material over a welded repair?
It isn't necessary to, being that you're using the same material that the part is made out of to repair it with. So if you have, like in this case, we were repairing a polypropylene bumper. So we used polypropylene filler rod to repair it. So once you sand it, if it's flat, smooth, you do not have to apply plastic repair material over it or filler repair material over it. You can prime it, block it, and paint it. It's not absolutely necessary. The only time you would need to apply filler is if there were low spots in it and you would need to build it up. But if it's nice and even and smooth, no need for body filler of any type.
Okay, great. Well, it's been a few minutes since I was actually in the shop doing repairs on bumper covers. So somebody that's a little more fresh with this stuff and going through and looking at this with John, I mean, what kind of, I guess, tips, tricks did you pick up watching John? I know that you're our most recent tech that's been out there doing this stuff. So
Yeah, and I wish John had given me some pointers before I stopped being a technician, but definitely fixturing with the hot staples, the aluminum tape, getting those two as even as possible, like John just said, will not only reduce further work down the road, but it will be a stronger repair in the end.
yeah, for sure.
Yeah, I noticed John was very diligent about managing the speed of his angle die grinder and other tools that he was using. He didn't have them running full tilt as he was working the area.
For sure. And I know we made this point in the last episode, but I think it's worth mentioning again. We always need to make sure that we look at OEM repair information to make sure that the vehicle that we're working on, that the vehicle maker doesn't have some sort of a position statement or requirement that says, you can't do the plastic repair, or it could be ADAS related, right? You've got an ADAS system in that area, and there's going to be specific requirements. We need to make sure we follow those as well.
Absolutely.
I think there is, as John just demonstrated, there is a place for this type of repair where a shop may make the decision that they're going to do a plastic repair, and I think he's shown that you can really do a quality repair using this welding technique.
And taking into consideration some of the supply chain issues that are out there, it opens up perhaps someone's mind to looking at these options.
Right. So next question that we've got here, John, is what is the benefit of welding with a nitrogen welder versus a hot air welder?
So the nitrogen serves as a shielding gas. It prevents the plastic from burning and oxidizing. When welding with hot air, the oxygen in it will burn and oxidize the plastic, which makes it brittle. And in this case, with a bumper, it's flexible and it needs to stay flexible. So when you weld with just hot air, that plastic it hardens and becomes brittle, and it's just detrimental to it just causes the plastic to, I guess, change its chemistry. It's not as flexible as it needs to be. So the nitrogen just prevents that burning and oxidation, and it allows the plastic to stay in the same form that it was in before you ever repaired it.
Okay, makes sense. And this next one is something that I've heard before in the shops talking with technicians, and the question is, can you use other gases other than nitrogen when welding on plastic?
Sure. You can. We recommend nitrogen because it is an inexpensive gas, but you can use any inert gas to repair plastic with. Argon, for an example. You could use argon gas, but any inert gas will work when nitrogen plastic welding. Again, we recommend nitrogen because it's an inexpensive gas.
Okay.
So we definitely would want to stay away from our mixed gas where we're doing GMA mag welding.
Absolutely.
Yeah. Okay. Next question here is regarding, you talked about room temperature and making sure that the repairs had cooled to room temperature before proceeding to the next step. And the question is, there are many different regions of the country where room temperature might be a different temperature. Is there a more specific temperature that they should let the welds cool to before they move to the next step?
No, there isn't a specific temperature. Just depending wherever you're at, the room temperature of wherever wherever whatever region you're in. You just want it to cool down from being hot, like it was when you were melting the plastic. When the plastic is when it's hot right after the weld, it's very weak, because the plastic is melted, and it's hot and it's very weak. But once it cools to room temperature, or just cools down from as hot as it was from welding, then it will have its strength.
Okay.
So you've got that hot material. You're looking at then getting it to where the rest of the part and that welded area are at the same temperature, whatever that
Pretty
happens
much,
to be.
yes, sir.
Now, is there anything detrimental in using cold water or something like that to help cool it down quicker?
No, we actually do that from time to time. I hear of technicians doing that. You can use your shop compressed air to cool the weld down, or water. If it does affect the repair at all, it is not enough to matter. In the years of doing this, I've done it both ways, and again, I've heard technicians also say that they've cooled it with hot air and have never had an issue with it.
So, thinking about shop air, I'm hopeful that most shops out there have good, clean, compressed air coming out of those air hoses.
Mhm. Yeah, and of course, you definitely want that clean shop air running through your nitrogen welder to begin with. So, yeah, good clean shop air is a must.
Yeah, for sure. TJ, any last thoughts?
Nope, just if they missed the first video, go see it on demand. And I hope that John will also be here next month when he comes back and shows the very neat tricks he did for some headlight tab repairs.
All right, great. Well, with that, we'll go ahead and end this session. Again, if you're watching on demand, you can go to Repairers Realm at i-car.com to submit any questions you've got. And John, thanks again for joining us, and we look forward to meeting with you again next month when we talk about those headlight repairs. And Jeff, TJ, thank you.
Thank you all.
Thank you, guys.